series of webinars in this. Today we have Unity Ball Scripting by our well-known Mr. Aviraldwivedi, and he is a founder of XRDI. And he was he's been a pioneer for this technological gaming, AR, VR, and a lot of other areas. And he has been a finding person and doing a research on a lot of these elements. And he's been a very interesting person on while we discuss on these topics and everything. And he's a very right person for this particular topic. And today, this topic will be giving an overall understanding for the designers to come out with their game development ideas to complete and full-fledged in a concept using the Bolt visual scripting in Unity. Yes, I once again welcome you, Aviraldwivedi, on behalf of IMSK, and looking forward for an interesting session from you. Over to you, Aviraldwivedi. Javi?
Thank you, Ajay. It is a wonderful introduction, and I'm really amazed with this community. In such a less time, you guys have did so much. I'm sharing my screen now, and I know in the stream there are a lot of designers, and I'm really sorry to all the designers that I'm going to use today Canva, because I know what designers think about Canva. So I'm going to start with Canva. I have a small presentation, and then we'll talk about how to start with no code programming. Okay, so the target is to start with no code programming. I'm going to talk about a little bit of how programming came through here, wherever the programming is, and where we are leaning towards and where we are going to. So this is the entire graph which we are basically going to cover in this talk. So bear with me. Be a little bit patient, because there will be a little bit theory as well, but I'm sure this is interesting and this is something which you guys would love to explore. So yeah, let's start with first that who I am. And thanks for giving me this opportunity to start with this. So I'm Aviraldwivedi, the founder of Extended Reality Developers of India, and one more company called Untitled Studios, where we give services to virtual reality and augmented reality products. I've been a part of several sessions, especially in 2020, since everything is online. We've been part of 20 plus universities and given their students a lot of information and democratization of augmented reality and virtual reality. So let's start with the very history of programming. This is very interesting. Computers existed not more than 100 years, right? So it's a very recent invention, but this guy, which is known as Hero of Alexandria, this particular dude has invented something like this sort of a machine, and this particular machine was basically constructed with using a lot of cables, a lot of strings, and these strings were used to construct and give an output of some sort of animations and the outcome. But the best part about this machine was it could be programmed. So this guy was literally being able to program this thing, which means you can rearrange the strings in one pattern and the output will be completely different. So I have added a simple demonstration, very simple mechanism demonstration of this. So I'm going to showcase this. So this is how it was constructed, and this guy is literally the mathematician, engineer, graphic artist, programmer, visionary, and philosopher of his time. So you can see the output is this sort of images, and these sort of images are completely procedural, which means he can change how the string works, and these images, which you can say the graphic engines before the digitization and before the graphic engines were there, he envisioned everything by his own, and he created these sort of simulations on these machines. Literally, this guy is known for so many things that he is literally compared to you know whom. He is literally compared to Tony Stark of today's time. If he has access to electricity, if he has access to all this sort of technology what we have right now, he definitely would have been much more powerful, much more bigger. So let me just make his photo a little bit bigger here. Okay, now he looks very good. He is literally known as the hero of Alexandria. Actually, his name was Heron, but his name was also rhyming with something in Dutch, so he has to change his name. So something like that. Now, let's come to when we started calculating using machines. So it started with the invention of abacus, and it was started 1200 Common Era. So in 1200 Common Era, they started abacus, and it's literally a counting device. But only problem with abacus and why we cannot put in this slide is basically it's not a programming device. Now we get to understand this particular distinction between what is programming and what is not from the backend itself, because it is something which is built for one function and it can do only one thing, like calculating, right? It cannot do multiple things, and we cannot redesign it for multiple things without actually breaking it and reconstructing it in another way. There is no way to reprogram this thing. So programming comes from reprogramming, or you can say whatever we can program is basically the very meaning of programming is we can change it at our will without changing it too much. Okay, so Charles Babbage, literally known as the father of computing, the father of computers, invented two things, actually three computers. He invented or designed, I would say, the differential engine. And these are the parts of differential engine. It's a very interesting story. One reason why everybody in this era as well could relate to Charles Babbage is he picked a project and he didn't complete it, and then he said, okay, I know like something else and I want to do that and not this one. So he came up with the idea of creating something called differential engine or difference engine, and he was working on it and he got funded to create this difference engine from his university. And when he started creating, he came with an idea of even a better machine which will look this difference engine off, and that machine he named as analytical engine. And he couldn't get the funds, or he it was not feasible at that time to create this analytical engine, at least for him. So he designed it, and the designs was so precise, so elaborated, that people actually created this difference engine further. So it's created in it was completed in year 2002. So even after his complete design of 8,000 plus part, the difference engine was created. uh, okay, one second. How many audio visual scripting in Unity? Okay, I'll
No, no, no.
answer this.
It's just to aware with the audience point of view. You can
Okay,
continue.
okay, I was reading that. No
Mm.
worries. Okay, so Difference Engine 2 is his second invention, I would say, because this guy literally invented two machines, or at least the design of two machines, which were like way ahead of his time, and literally gave birth to actually a computing device which can print result. This was earlier designs were like it was showing result on some sort of gears, but this difference engine 2 was actually printing result in some sort of Chinese printing machines. So they used to have this printing machines, and he used the same technology, the same gear, and the outcome was printed on a paper. So this was like a computer connected to a printer, and it was all mechanical. It was controlled by a simple motion of hands. You just have to set the input condition, which is like what you want to feed in, input one, input two, and and start rotating, and everything machine does on its own. This technology is such advanced that in 17 years we built it. In 1985 we started building it, and in next 17 years we were able to complete it. In 2002 we completed this, and it's right now in I would say It's right now in Silicon Valley. They have this computer history museum where they have this device, and it still works. I have added a video of how this actually works. Let me just show you a little bit of working mechanism from this. Okay, I just want to show you one frame of exactly how it works, and it will literally amaze you guys because it amazed me when I first saw this. So they feed the input and they keep rotating it, and based on how fast you rotate, the faster your computer computes. And this is how beautiful the gears and everything works together, looks together, and it just looks like an alien technology which is working, a machine which is mechanically thinking. And that's how the first computer was designed. He didn't created it, but he designed it. Okay, it was created much later. So everything is now you can see so many print heads are there, and they organize in such a way that they create the final output, and then that output is printed on a paper based on with the help of ink, of course. Then it is printed out on this paper. So that's how complex this machine is. And of course, he took a lot of time, a lot of energy, and the result was amazing. So Charles Babbage, amazing guy, but he created something which never existed at that time. And this lady, you guys can't see her name, so this lady, Ada Lovelace, so what she did, she is known as the first programmer in the world in the history of programming. She's the very first programmer, and the cool thing about is she was a programmer of something which does not even exist. She created the program for analytical engine, and when they constructed years later of these people passing away. Then they feeded her program into this analytical engine, which is a hypothetical machine which was never existed at that time, and that program run. She knew that by just feeding these two inputs, she could do much more than just adding or subtracting. So she actually designed a flow chart for this two input process, so which is like way ahead of time. Now, let's also talk about Alan Turing, of course, because I'm going to talk about only the people who actually made computing, who made big changes in computing. Because of them, we right now exist with our laptops. Otherwise, we never had laptops. We might have rooftops because the computer were taking the entire room or something. So you have to put your computer on roof to safely use it. So now let's talk about Alan Turing. So in Second World War, he actually decoded a lot of messages using his technology, and his technologies was so ahead of time. He created this Turing machine in 1936, and he also uh, this Turing machine was completely mechanical, and it was not working in terms of ones and zeros, but he gave the very foundation to the binary, the way now modern computers works. Yeah. Now we are in the era that even modern computers are considered as classical computer when we are talking about quantum computing or something. But he literally gave us the very binary and the way and the very promise that everything could be done with something called universal Turing machine. So he gave the concept of universal Turing machine, and the concept looks like this: there is an input, there is an output, and everything in between is the finite program. Okay, now what is a finite program? Finite program is basically a program which ends. Okay, so it's a very complex thing, but he came up with a problem there that there are two kind of program, one that end and one that never end. So his machine could solve any program which is finite, which can any at some amount of time, which program can end. uh, so he gave this concept, and this concept is still used in modern computers. So he literally laid out the path for other computers. Later on, we got introduced to languages. Of course, we need to, before that, if I talk about even 1 or 2 years back, than 1949, there were people who used to put punch cards, and in punch cards, and then also there were women who used to bind these sort of code. The programmers were initial programmers was all the women, and the reason was that they were literally much better than men to not make mistakes while writing code or while suing the code, because it used to sue on the on some sort of punch cards formation. They used to literally sue that. So now people came up with assembly language finally. So what assembly language actually was doing is it was encoding all those bits and bytes like zeros and ones into something called codes. And these codes was like a combination of a set or a combination of something which combine everything into one pattern. Okay, so a recognizable pattern initially, like some codes, like some error codes and things like that. So they, so that they can track problem, they can, the idea was to humanize whatever the computers was doing, because prior we have to use people which are called compiler. So literally compiler was not a thing machines used to have. Compiler was actually a job profile, and compiler was the only job profile which lose due to automation at the first. So let's talk about shortcode. Shortcode initially came up, and it was literally the very first high level language. Shortcode, in shortcode, the idea of high level language is you are not writing codes, you are writing language, like do something, go to there, or something like that, for loop or something, things like that. Whenever you see code right now, it's written in English. It's no matter whatever the language is there, it's written in English, and machines at their end understand only zeros and ones, but you write in English because of the invention of short code. They laid out the foundation that it could be done, and they did it. Then Fortran is basically still in use, and all these languages are basically still in use. Smalltalk is the biggest attention seeker here, and the reason is Smalltalk was not very popular, but the reason why it's still here is Smalltalk was literally the language which set the foundation for visual scripting. Okay, let me tell you how. Other languages are based on the flows and everything, based on object orientation and things like that. But small talk was basically the language which focuses on messages between one object to another object, and which is the key fundamental of visual scripting as well, which we'll see. And then 1972, the same year, C came, and after that, C literally laid out the history. Even to this day, if I have to recommend somebody to start with literally programming, I recommend them to start with C, because if you understand C, if you understand the very concepts of C, you can do everything. Okay, unlike Python, if you know Python, you only know Python. Okay, so Scratchpad. Okay, so now we are in the era of finally the visual scripting. Okay, so this is, you can say, the earlier Photoshop, the Photoshop before Photoshop. Scratchpad basically was created by MIT at that time. MIT created this Scratchpad in 1963, and let me show you a simple video of Scratchpad in which you can look at the technology that they can draw triangles, and these shapes were actually splines, so that computer later could also fix the drawings. So when somebody created, it's not that mathematical, but they can also, the system could also make it mathematically accurate. So now the line is not that straight, but system can correct it. It can make, you have the option to make it a right angles or something. Okay, so this is short. This is Sketchpad, 1963, and this is a greatest invention. You guys right now have different kind of what I don't know, pads in which you draw. I forget the name, though I have one. Okay, now let's talk about the Grail. The Grail is basically the language which is very similar to today's language, even because in the Grail you literally have the flowchart kind of structure where you can start forming your own code. Similar with PyMaglin. and similar with other uh, outcomes like 19 Prograph, which came in like 1983, Visual Studio 1997. Visual Studio is unique because it's right now even we use Visual Studio, and second reason why it's unique because it set the foundation of hybrid programming, which is still in a very wonderful concept. And in hybrid programming, I mean is there's a front end and there's a back end. So you design your front end and you code your back end, and this sort of structure Visual Script gave birth to. Then Scratch. Scratch is literally the foundation of today's visual scripting languages. And Scratch came up, was designed by the same people, not same people, same organization designed Scratchpad. So yeah, very good, I would say, progress there. Now let's come to the future of programming languages. So let me tell you why I'm telling this the future of programming languages. So you might have aware of Blueprint, which came up with Unreal. You might be aware of CryEngine, which come up with similar Blueprint kind of concept. And finally, now Unity also has the Bolt. Okay, so we are going to take a look at Unity Bolt in this session, at how Unity Bolt actually works. But the visual scripting is now being adopted by every sort of computing or every sort of visual uh, product. And the reason is the intuitiveness and the low complexity. And you can basically create much more in less amount of time with these sort of programs. Okay, I'm going to show you exactly that. That what is the difference. So Facebook Spark has a very good tool where you can design your own logic. Uh, okay, Rec Room is literally the future. Let me go back and show you one of the Rec Room thing. Okay, so let me just show you. This is Rec Room, and Rec Room is a virtual reality software. It's a virtual reality game, but you can design your own simulation. You can create your own simulation, and you guys might be aware of these sort of nodes. These are called nodes, and you manage the input and output between these nodes. If you ask me that what is programming, it's literally all about nodes. So every node has an input component, every node has an output component, and in between there's a processing. Okay, so we take inputs and we do processing, and yeah, things simply works. Okay, so I'll come to these concepts. But this is happening in virtual reality. I've coded Rec Room. I've coded many things in Rec Room, and it's fun way to teach kids how to code. And a lot of great programmers are creating amazing things in Rec Room. So now, why I'm putting these two images together is from this hero guy, the hero of okay, a hero of 10 AD. It's like so many years, almost 2,000 years back, and now after 2,000 years forward, we have changed a lot in terms of technology. Still, the fundamental concepts behind what this guy did and the fundamental concepts behind what Rec Room is doing is exactly the same. The very concepts which are used there are still in use, and that's what we are going to look. Okay, so programming is something which is not much about on which kind of languages you are coding or on which kind of program you are coding. It's just about the very fundamental need of making something or generating some sort of output or coming to some sort of conclusion, taking some data and processing it in your fundamental way. Okay, so now let's quit this slide and let's come up with a practical code. Okay. I had trimmed my slide to like 20 pages less. So because I need to focus more on the practical part. Okay, so let's do it. Let me just pick a version through which I want to run. Let me name my project. In Unity, you require to name your project. So I can, let's name Bolt Scripting Demo. Okay, so let's create this. Now Unity is creating a empty project for us. Even in empty project, there are going to be a lot of things which Unity will store for us. Hmm. Unity is taking import time, which it does, no matter how fast your PC is. But this is something very natural with Unity. Okay, so let's see how to install uh, Bolt. Okay, so to install Bolt, let's start with finding the Bolt. So I'll type Bolt and then I'll type Unity. Okay, so I'll get the first link, which is like asset store link. Let me just go in this at store link, and here you can find Bolt is free. So Bolt were not initially the Unity's product, but then Unity find it very useful, and it just worked like a charm with their existing game engine, so they purchased it. And you can see how multiple screen works. You can see multiple features and then reviews and things like that, but we are not interested in that. So let's just open in Unity. It will get opened in package manager. Previously Unity used to had asset store and I asset store tab, and I used to love asset store tab because that was much more better than this package manager. But now Unity does not have the asset store tab, it has the package manager only, and it takes time to search your project, to fetch your project. So it's doing exactly that for us. Come on, package manager, fast. Okay, very good. Let me just restart Unity because that's Unity. Takes some time. You have to, the first thing uh, which comes with Unity, whenever you are learning Unity, first learn patience because it comes very handy when you are working on Unity. Okay, let's see how package manager is doing. Okay, awesome. Let's try to open now. Open in Unity. Okay, uh, worked awesome. So what I can do, I have already downloaded. If you hadn't, it must have been showing you the download button instead of import. But I have downloaded, so I can press right away import, and it's showing you whatever it comes with. So import all. Don't uncheck any item, otherwise you'll face trouble. Okay, so now we have the bold package and it will ask us some quiz questions. So let's say next, it will ask you human naming versus programmer naming. So it sounds really funny, but human naming basically says it will not uh, craft the variables the way a programmer does. Like if you write down like add force, it will not work in Unity. But if you write down add force such way, it will work for Unity. It's the same convention programmer use. Okay, so in this, make sure you use this one, and there are two reasons for that. One reason is that you are going to keep learning that how programmers code, so you are leaning more and more towards programming, or at least understanding the programming. And second reason to choose so because rest of the community is choosing the same option over and over. Okay, next. Okay, so we'll get all these sort of concepts like objects, what a bool, int, raycast, and things like that. So everything you need to require a game, it's already there. Or everything you, of course, there are ways to create your own these sort of behaviors. It's importing. Okay, so everything is imported now. Now what we can do is basically we can, if you are not already aware of Unity, let me just guide you a little. Okay, so let me just give you a little bit of brief, like this is the scene, and for example, this is called hierarchy. Everything which is present in hierarchy will be useful for our scene. Let me just show you a little bit of uh, sense to what I'm talking about. This is scene, this is called game, and game is basically whatever your camera sees is your game. And here are what is the aspect ratio you want to run. It's going to be 4K, 1920 by 1080, whatever the you want to. And every window is dockable, so you can arrange the window in whatever the way you want to arrange. Okay, so that's how you can basically use Unity for your uh, requirement. Let me just create in hierarchy, right click and create 3D object, then create one cube. Okay, so now if I have created a cube and click on camera, and camera has this sort of white lines, and you can, I don't know how visible it is, but these white lines are covering this cube. And since they are covering this cube, you can see the cube here. Here you can do anything, but you can't touch it because we have not coded any input. So now let me just select cube, make it somewhere here. So you can see the cube here and the same cube here. And if I press W, it gives me some sort of arrows. I can move it up, down, and you can see the same change in this perspective in here. And this is always looking from the perspective of camera. If I move it closer, you can see the object is getting closer or not. You can see, yeah, like this. Okay, so this is how object works. You can uh, do basically three fundamental things to any object, which are these scale. These are scale, like I can raise the scale of object. Let's make it 5 here. So you can see it's raised to 5. Previously it was just 1. So you can change the scale of objects. You can rotate the objects in whatever the way you want, okay? X-axis or Y-axis or Z-axis. In whatever the way you want to scale, rotate, you can give them values and it will rotate. You can also set the any position. So wherever you want to set them, you can simply set them. Okay. So these are fundamental properties which are related to this object. To render any object, you guys are artists, you already know what render means. To render any object, you need to make sure it has two components. One is mesh. Mesh is basically the very FPX or the very vertices data of what the object is need to be rendered on the screen. That is contained in mesh, and you cannot do much with mesh. There are not many options. And the other one is mesh renderer, and this basically manages how these data, which is the cube mesh, is going to be visible on the screen. There are several properties in the mesh renderer, but the most important one is this, which is called material. So let me just show you how material works. So let me create a material and name it M0. Okay. Let me save my scene. Okay, this M0, I can change any color. I can let's say yellow, something yellow. Okay, and I can drag it here, or I can assign this into the element section, and now this cube is yellow. Okay, so that's how you basically give properties to your cube. This is box collider. This is responsible for all the physics. There is one more component which is responsible for the physics, and it's called rigid body. Okay, so let's turn off gravity for now, otherwise it will fall. So let me give you a simple demo. Okay, let me turn on, and what will happen? Nothing will happen, because I'm not giving any command, but this is physics operatable. So all the physics are applying to this cube, and I can add gravity, start using gravity, and once I do it, the cube falls, because now it's using gravity, otherwise it won't. Okay. I can add forces to an object only if it has some sort of rigid body and colliders. Right. So I hope and these are assets. Here you put all your code and all your folders, and you have to arrange your folder in a good manner, like material and things like that, and put it in here. Okay, so in this folder you keep all your stuff. So okay, so let me write some sort of script, and then I'll do the same thing with bold script. Okay, let me call it script, and I'm going to create C sharp, and I'm going to create a script called rotate. Okay, so I'm going to add this script here, and okay. So usually it opens in this sort of script editor. I'm not going to scare you guys, but it's just you guys might be already familiar with this, but this is the traditional way of coding. Then I'll show you the modern way of coding. Okay. Public, not now, public vector 3, let's say vector 3, and let's call it rotation. All right. So I'll receive some sort of rotation from outside, and I'll assign it to my material. So let's say my object transform dot, there's a function called rotate. Okay, so transform dot rotate and pass the rotation. So this rotation is the same rotation which I'm receiving from outside. All right, and that is it. So just one question. One This update is saying that update is called once per frame. Okay, in when I talk about rendering, when I talk about computer graphics, the very fundamental things to computer graphic is that the idea of the object is a 3D thing, does not exist. uh, Object does not exist in 3D space. Okay, physical 3D space, but if suppose I'm moving this cube, the compiler, the rendering has to be more than 60 times or roughly 60 times a minute to be able to show that this thing is moving. Okay, if I don't do that, if I don't render, it will not move. Okay? It will not at least look moving. So let me just run this code. I've hardly added any code. Okay, when I'll run this, something will happen, and that something is nothing. Okay, nothing is happening, and the reason is I have not provided any value. So it is rotating, but it has no inputs for rotation. So let me add some input, and it started rotating. Okay, I have added input in Y. Let me add some input in X as well. So you can see a weird sort of rotation. Some input in Z as well. Okay, a very big input, a smaller input maybe. Okay, so now that this cube has life, it is showing how to move, how to dance basically. Okay, so and it's doing just that by just one single line, that is transform or rotate. Let me try to give you some sort of understanding that how this line works. So when we add this value, let's add some simpler value like 5. All right, why it's behaving. Okay, let me add some simple value like 5. Okay, then it's in the y-axis. Y-axis is the upper axis. It's rotating 5 around the y-axis. Now what is 5? 5 is the 5 degree. Okay, let me tell you what. So I have paused the simulation. What happened? So look at the number here. That is 165. What will happen if I move it one frame? This button is called step. It moves the simulation by just one frame. Okay. Look at this closely. What will happen to this number when I'll press this button once? 1. Okay. What happened? It changed by the factor of 5. Okay. Yeah. Tell me.
Avi, we lost you.
Can you hear me?
Yeah, we can you repeat this last word?
Okay, I guess network had issue. Okay, I was explaining that how this simple line of code is working. Let me add some simple value here. Okay.
The recording has stopped. This
Okay.
meeting is being recorded.
Okay, I have played it. All right. So I'm going to explain how this simple line of code is working. You can see it rotating. Let me just pause it. Okay. So let me try to explain that how this simple line of code is working. Okay. So I can pause the simulation. I can play the simulation. But once I'll use this button, this will move the simulation frame by frame. So when I'll press this button once, the simulation will be played one step ahead only. Okay. If I press 1, what happened? This number changed. This number changed. I press number this I press this button again. Okay, this changed to 160. Press again, 165. Press again, 170. Press again, 175, and so on. It's continuously changing by 5 degree. And why it's continuously changing by 5 degree? Because I'm saying so. So whatever the input is coming, and the input is in y direction 5 degree, so change in each frame, this update literally means change in this each frame by 5 degree, or whatever the degree that you want to change. Let's put some weird number, and it will get some same amount of factor. I put it 23. It's going to be changed by 23 in the x now. Okay, and when I play it in fast mode, you can see how rapidly these numbers are changing, because this computation is literally having 60 times a frame or something. Okay, if you can see here, it is happening 70, 90, approximately 90. Okay, so that's how graphic basically works. That's how a single frame is basically being prepared to be rendered and finally being rendered. All right, so let me come do the same thing with the help of bolt scripting. I'm going to remove this rotate script, and I'm going to add a different component here. Okay, so what I want to add, I definitely want to add the help of bolt. So I'm going to add bolt. and there is a section called bold. If you have added the package right way, which you probably, so it will show you the bold. Hold on, I came into audio. It's showing the bold, and it has several options. It has variable, state machine, flow machine. I'm most interested in flow machine here. Okay, so I added a flow machine. It is saying macro. It is a very important thing. It's saying macro. So the very environment on which all the visual scripting happens, the very stage is known as macro. So I'm going to create one macro, and I'm going to create by the name of, let's create it, create a folder called macros, macros. All right, go inside macros and create here rotate macro, rotate macro. All right, here I can also explain that what this rotate macro does. I can name it, give it a title, which is, I may or may not, this is completely optional, but it is a good practice to at least give this title, rotate macro. All right, I can give a summary like this will spin, okay, whatever you want to. All right, now once you done that, you can create convert, and it will create the very source embedded, and you have, sorry, you can create this once, and it is now created. Now you can click on edit graph. Here is the button. Once you find it, here is the button called edit graph, and it will create a flow chart. Okay, you can tag your flow chart any way you want, suppose here. All right, and here you got the same events. So what you had in Unity, once you start, you had two functions, update and start by default. Here is the same thing, update and start. What does update tell me? Update tell me that now my application is going to click one picture. Okay, update is basically telling me that now I'm going to click one photograph. So please make sure that all your objects are in the very correct position. Like a cameraman tells you that, okay, I'm going to take a photo, make sure your tummy is in. Okay, it's the same way. Update is basically letting us know that I'm going to click a picture. So whatever the changes you want to do, please make sure you do, otherwise I'm not responsible. Okay, and the start is telling us that I'm going to start now. Okay, it calls only when the simulation started, and if update calls whenever at each frame. All right, so the same concept. Okay, and now you need to understand some basic things, that this is called flow. Okay, this line is called flow, and flow is a very fundamental concept. uh, okay, once you suppose create this line by left clicking, if you want to, if you stop it, it will give you some sort of conditions, but I'm not going to go under that. So and if you want now it has logged your mouse, you can literally go anywhere with that. All right, anywhere. How you gonna rescue yourself? So just do a right click, and it will stop following you. And how you go back? So suppose you lost your screen, you don't know where you are, just do this, and it will show you that where you have lost, and make this again. Now it is in center, make it in center, and scroll and zoom. Now you are at the right position. All right, so by this you can go any way you want by scrolling. Okay, scrolling at the correct position. This is very important. Now I'm going to create something. I'm going to create, I need to rotate, right? Let's say rotate. I typed rotate here. It's searching for all kind of rotates. There are like 100 kind of rotates, and it's asking me which rotate to call. I need to call transform.rotate. And there are multiple conditions that how in what variant this rotate comes. I'll pick a very simple rotate variant which comes with three angles, like three Euler angles. Okay, so this is a rotate function which comes with three Euler angles. So okay, so let's put some value, like previously we put some value of 5 there. Let me put some value of 5 here. All right, and let's try to run this. Okay, So I've not made any other change. I'm going to run this. When I'll run this, of course it will compile, because now a person is not named a compiler, and you can see the flow is happening. You can see literally a lot of balls going from here to there, which means it's showing you the flow. Okay, it's the same thing previously as you imagine, and right now the frame rate which we are getting, it's much more. All right, which means it's, or even from the perspective of scripting or complexity, it's not that much. If I do two screen run, the frame rate will drop, because rendering is the most hyper thing which takes. So it's rendering two objects, two screens from the perspective of two cameras, so it's why frame rate is down. If I render only one, the frame rate will increase rapidly. So right now frame rate has increased. Okay, so this is a fundamental concept. You'll learn about frame rates and everything eventually. Okay, so that's how you rotate things. Let me add some weird rotation like we added earlier, so you can see the weird rotation is happening and it is rotating in that way. All right, how you gonna take some sort of input in this condition? Okay, it's already 3. I'll have to wrap up fast, so I'm going to tell you about inputs now. Okay, let's add some input. Okay, so let's say right click there and start adding, let's say jump. I want to add input called jump. So let me try jump. If jump doesn't work, okay, there are some jumps, configuration joints. I don't want that sort of jump. Suppose I want add force. Okay, and there is a force called rigid body, add force, and force mode. All right, so there are few sort of force mode: velocity change, impulse. So let's choose impulse. All right, and we need to add the force. So I'm going to add some sort of force here. So let's see how I'm going to add a force. I have added force. Where I want to add it, let's say I want to add in the y direction, and this is a position kind of thing. So when you'll add it, it will make change in the position only. There is something called angular velocity which will make change in rotation only, but this will make change in position only, right? So if I am suppose adding 5, it will make change in position only. If I'll make change in suppose this, it will throw from the angle 5 in y and 10 in z. So let's add this sort of weird sort of force: 5 in y, 10 in z. Okay, and let's add. Okay, let's add input. Let's add an input called key down. Key down. Okay, we got input dot get key down. Okay, this is a very useful one. We got key down. All right, and which key we want to take input of? Let's say here you'll select the key. There is none, and you'll get all the keys which they are there on your keyboard. So you can select, let's say space. I want to, on the press of space, because that is what everybody does. I want to do something. All right, so I can select space. All right, on the press of space I need to do something. Okay, this thing is called output, this thing is called input. All right, there are two components. There is one triangle and there is one circle. So the circle is input and output, and the triangle is flow. How flow works we'll understand right away, and flow is a very important concept of any programming language. All right, so let's feed in. If I try to connect this, it's not happening. It's not happening. If you will collect even this, it's suggesting that you should use a branch. Okay, now let's see what is a branch. Let's say I want to use a branch. All right, sorry, yeah, like this. So it says you can connect, but if you can use a branch. So okay, all right, I want to use a branch. So now branch is basically a deciding factor. If you are getting this input, you will get two options. If input is there, if input is not there. If input is there, it's going to be this true. If input is not there, it's going to be false. Okay, all right, you got it. So you have to make sure that you want to do things when the input is there or not. All right, so how you gonna do it? Let's say if I want to do it when input is not there. All right. If I want to remove this, I can do a right click and it will notate as red, and I can uh, stop pressing the right mouse key and it will disappear. So that's how you link, and that's how you unlink. Left click link, right click unlink. All right. So I want to connect it with true, so this connects with this. All right, this connects with this. Okay, makes sense. So whenever the flow is true, the flow will go to here. If the flow is false, it will stop it here, it will not go anywhere. If you want, let's say, if flow is not here, go somewhere else, so you can here create some more things to do. It's like if else condition. If you do programming, you know if else. It's the same thing. Branch is the same thing here. All right. So that's how you create a branch. Okay, so now input is there and I want to do something. So I have added what I want to do. So first make sure, do you want to have the rigid body? Rigid body is already there because we added that. All right, rigid body is there and that is not using. Okay, so let's see what happens. Let's see what happens when we run it. So now I want to run it. What happens? Okay, this is running, this is running, this is running. Now what is happening? If I press space bar, what is happening? Nothing is happening. Why nothing is happening? Because I have not tell my computer that when to do it. Okay, I have added that press it on this particular functionality whenever the space is there, but this is not connected to the program. This is my update function. What I can do, I can pass this flow to here also. You can see some more balls are going to there, like water flowing to there as well. Now this flow is on, right? And now let's see what will happen when I'll press a space bar. Okay, 1 2 3. All right, I'm pressing space bar and nothing is happening. Why nothing is happening? Okay, it says key is added now. Key space, that is, oh, key space, and then okay, I got it. Okay, so you have to do, make sure. 1 second. Again, we lost it, so we can go back and we can go forward. You can also press control to control zoom. Okay, connect the flow this way. Okay, but also there's a gap. You are passing the input, whatever the input is there, you are passing, but you are not passing the flow. So flow passing is also important. So now everything is lit up. If the flow is disconnected, you know that this function is not going to be called. It's like the light is off for this. It's not highlighted. Whenever you will pass the flow, now this function is into consideration. You know the code flow can reach here. Now let's do the same thing. Also, one thing to make this appear good. 1 second. Just 1 second. Array here. Okay, go to camera. You can see better with the solid color. So let me pick some sort of this sort of solid color. Let's say. All right. Some solid color, any sort. Yeah, something dark like this. Okay, this looks good. All right. So now let's run this, and now you can see the flow is complete. Everything is complete. Now let's see what happens if I press it. I press the space bar, and what happened? It flew away. All right. Now we can. If I press it again, it flew away faster. Okay. If I don't press the space, you can see it's not this particular. Whenever I press space, this will lit up. So I press space. You can see the rigid body is getting lit up whenever I'm pressing space. Okay. Now press space. So that's how code flow follows. The code flow will not go here unless the space, you don't press space, and on the true, the code will lit up. All right. So you can branch different modules as well. Okay, let's try a different sort of module. where it only rotates when I press some key. Okay, you understood the input, how input works, and let's try to do the same thing. So I'll delete this. I don't require this. So right click and delete. Okay, and this I'll have to remove this connection. So right click and remove connection. Right click, remove connection. I put it there, and let's say whenever I press this, uh, this function will lit up. Okay, I literally changed the very condition, the way how it works, without changing any line of code or anything, and everything is changed now. All right, you'll see how this happens. So I have added key down, but I can change it to let's say I don't want key down. I remove this as well. So this as well, this as well. I add one more unit. So if I add get key, not key down, this time I'm getting get key. Okay, and there's a difference. You'll understand the difference. I'll show you how you will understand the difference. All right, so let's connect it here. Let's connect it here. The flow is there, but the input is not going there, so I'll connect the input as well. Now everything is there, right? The flow is there, the input is there, everything is there. Now let's run it. Let's see what will happen. So, and the answer is, you all know what will happen. Nothing will happen, right? Why nothing will happen? Because the flow will reach here only when I'll press the space button. So let's press space button. Click here. Press the space button. Okay, sorry. The key again goes back to okay, null for some reason. Okay, I press the space, it start turning. I stop pressing, it stop turning. Press the space, the rotation turned up, and I can also do reverse at runtime. You can't do this with code. I can how I can do it. I remove this. I can draw here from here. Now it will running. Now it is running whenever the space is not pressed. When I'll press space, it will stop. Okay, I stop pressing space, it's running. I press space, it stop. So that's how you craft basic logic with uh, Bolt, all right, or any visual scripting tool. This tutorial is not just for Bolt; it's for any visual scripting tool, because the conditions and the things, the very mechanics is same across. It's same in all sort of programming languages. Okay, so let's remove this. I want to make it happen only when the code, when I press it, it's happening only when I press it. If I want to change the functionality, it happens only when I don't press it. It's already happening, rotation is already happening. I can break whenever I press this function. All right, I hope you understood some of the basics of Bolt. I don't have much time now, so I'll wrap it up pretty quick. If you have any questions, I can give you like 5-10 minutes.
It was a very great session, and guys, you can unmute yourself and feel free to ask your questions. We have another 3 more minutes to another 12 minutes to complete the session. So feel free to ask your questions.
Yeah, any other question, guys? Can you guys unmute yourself and ask? Is it possible, Ajay?
So what is the ball scripting usage in the industry, Avi? What is
Uh,
the
it's
usage in the
mostly used in rapid prototyping. Usually, it's not. I won't say it is very heavily being adopted in the industry. People still prefer scripting, but it's changing day by day. It will take some more time to be completely a no code thing, and especially to for programmers to adopt it. But people are changing their minds. Even 1 year back, I never used to code on no code tool. I never used a no code tool. But once I used Facebook Spark was a wonderful program. And when I used it, I realized how powerful the no code technology is. literally the fundamental concepts are very same to what you do with the program, and it really doesn't matter that you are writing code or you are doing it visually. It really does not really matter. The algorithm process, the way how you think, remains the same. But again, industry will take like 5 to 6 years to adopt it for like commercial projects, but right now it's used for prototyping for sure.
Oh, that's a great input. And talking about the designers, those are game designers. So we are looking forward and motivating them only to motivate them only. I think this concept came into many of the game engines. So
Of
what
course.
is the problems do you think they face during using this, like kind of on a general for all the beginners? What kind of a problems they face?
The only problem I would say there is the mindset, because everything you require to start with scripting or start with any sort of game development is already there. The technology which you are using in today's time was used to cost like millions of dollars. If I talk about early 2000, the same sort of tools like Unreal used to cost millions of dollars. The license used to cost this much. But now the technology is available literally for free. You can use them, you can start building things. The only thing is stopping us right now is the mindset that it's going to be complex. It is literally not complex. You can start doing it and you'll learn, you'll fail, you'll learn. And there are so many tutorials, there are so many people creating their beautiful, wonderful channels like you have, and or like I have on XRDI. So these sort of people are creating the way easier for new generation, and it's becoming easier and easier. Previously used to have a lot of documents, a lot of support communities, and now it's everything is just on another level. So getting started is getting easier and easier day by day. Only thing which I think is problematic is the mindset that you feel that it's hard, but once you start doing it you find it easy.
That is a really great input, we again. Uh, Talking about the complete structure development, talking about from the basic till the advanced level, which you demonstrated is good that many people come to know how to use visual scripting. So what is your thought process in developing a complete AR application or a game development or whatever it is using the visual scripting? What do you think really there is a gap between a programming, so using a development using complete programming and using visual scripting? What is the difference between that? Major differences.
Right now, I would say, okay, so the only I would say the problem you could face is the completeness. All right. So Unity and Bolt on their end has already created all the modules which are like most commonly used, and they are like 80% of the modules. But when it comes to third-party APIs, when it comes to something which Unity is not really taking responsibility for, then they are like third-party softwares for Unity. So then Unity and Bolt cannot do nothing about those softwares, and you literally have to look for support. However, on the code, you can do it whatever the way, and they are literally the very exceptions. And the Bolt, the good thing about the Bolt is it's provide you the very feature or the very compatibility of scalable coding. It provides you the very idea or the very I would say liberty to whenever you want, you can switch to normal standard programming or code with code programming whenever you want. Whenever you came across a third-party software, you can because it supports the bold script as well as the normal script at the same time. So whatever you create, they are mutually compatible. So I won't say you'll face any good problem, or in most of the cases, in like 80-90% of the cases, there are not going to be any problem. But yeah, that in the third party softwares or the third party APIs or something which is very new, like very latest update or something, some experimental beta technology, then you could face some sort of uh, struggle.
Development life. what while have you used anywhere this visual scripting for the entire development, and what are the problems you personally as a developer you faced it on your product development or application development, any kind of an application or product development?
Okay, so I'm a hardcore programmer and I literally use the ways Unity has never used before in the world. So I literally push Unity to the limit sometime. So for me, visual scripting is really not the thing, but it's really good for people to who want to do rapid prototyping, or who are like designers and they are starting with programming, or the future programmers, because the future programmers are definitely going to adapt it. So for them, it's definitely there. However, not in Unity, but in like Spark AR, which is also a visual scripting. They have the visual scripting backend. So there, I have did several filters using these sort of visual scripting. So and that is very convenient, and that is where I found that how cool this visual scripting could be. So of course, you can find your own way, and you can start somewhere and keep hopping on one technology to others, and that's how everybody learns.
I think that's a good lead actually, which you gave for the upcoming session, which we can expect from you on the Spark AR with visual scripting. It's
Definitely, we're
really a
gonna
good.
do some session of Spark AR as well. I did
We are
in one in past, but I'll definitely do more experiments on
Yeah,
that.
definitely. Looking forward for you. We will be. Let's collaborate and let's do it with IMSK with upcoming session on Spark AR with visual scripting. I think many of the during the session, I think a lot of people were chatting with me that they were asking for an AR VR developer with the easy method with the, because there are a lot of designers who are very having a lot of interest and a lot of concepts in developing a lot of cons in games or an application, but they are scared about programming. So I think the visual scripting or in Unreal we have Blueprint, which is opening the doors for the designers to come out with a proper completed product, which they can happy to see whatever they have in the mind. Now they can see as a complete product. I think that even you agree for that. You have anything on to say on that?
No, of course, Unity is bold, and Unreal's Blueprint. These are very powerful methods of creating whatever you want to, whatever you have imagined, whatever your dreams are. So, suppose if you are lacking any problem regarding code or anything, you can connect to anyone in our community as well, because not everybody knows everything. And I'm sure whenever I'll get stuck with graphics, or whenever I'll get stuck with some model poly count or something, I'll get back to your designers. That's how communities collaborate and make use of each other's superpowers. So definitely do collab and do learn with these sort of engines. Whatever the help is required, I'll definitely be there for you all.
That's I think that's a really wonderful information which you told just now. I think there are a lot of newcomers here and a lot of people who are interested students are here. Those who are interested to jump into game designing or development. I think IMSK and law XRDI and a lot of other community is there to help you all to come inside the gaming community, and which is with all your support. I think let's make our country proud, and let's bring this community and sectors in a way up in the global market with all your support. And really happy and thank you on behalf of all the participants and on behalf of IMSK. Thanking Avidivedi. Really thank you for a wonderful session. And to all the participants, we are looking forward for a lot of interesting sessions are coming up in IMSK, and which is a very like we are looking forward. We are picking up the sessions based on the current scenarios and current issues and current problems, which we help a lot of designers and a lot of developers. We try to do the best as possible, and I think we have a lot of pioneers and like Javi and a lot of other pioneers are there with us in our various communities to help you all. Looking forward to collaborate and work together. Thank you, and thank you one and all to join on today's webinar series of IMSK. Thank you for joining for today's session.
Thank you, Ajay. Thank you very much.
Thank you, Avi. Thank you all. And look, let us see on upcoming next Saturday with a very interesting web series coming up. And don't miss to keep us following up in